everybody, and welcome to this video on the past paper series. In this video, we're having a look at the GDE preliminary paper for 2020, paper 1. We are starting with the calculus section. Please make sure you review the series on calculus before watching this section, and then try it first before watching this video. Okay, so let us start. So for question 8, it says determine the derivative f dash of x from first principles. So that is quite simple and it's a standard question. So you need to know how to get standard first principles. So the first step is to calculate. So we've got f of x is 2x squared plus 6x. The next step is to get f of x plus h. Now, f of x plus h is what we get when we replace x plus h in every place that we see x. So then simplifying this further, we get 2 times x squared plus 2xh plus h squared plus 6x plus 6h. I'm going to simplify this further. So then I'm going to get 2x squared plus 4xh plus 2h squared plus 6x plus 6h. Then what I'm going to do is write out, oops, this is a minus 2x. Sorry, that should be a minus. So let's just change the signs. That should be a negative, that should be a negative. Okay, so now let us write out the definition of the derivative. It is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Now substituting those quantities in from our formula above, f of x plus h is minus 2x squared minus 4xh minus 2h squared plus 6x plus 6h minus 2x squared plus 6x all over h. Our next step is just to distribute that minus, and this is the step that's commonly left out that leads to a lot of mistakes. So make sure that you distribute that minus to every term in the second bracket, so not just the first one. So 2xh minus 4xh minus 2h squared plus 6x plus 6h plus 2x squared minus 6x all over h. So then what we'll see is then the minus 2x will cancel with the plus 2x, and the plus 6x will cancel out with the minus 6x, leaving us with, okay, so if we simplify that, it's the limit as h tends to 0 of minus 4xh minus 2h squared plus 6h all over h. So our next step is to factorize by h on the numerator so that we can cancel it out with the one in the denominator. So doing that, we get ho times minus 4x minus 2h plus 6 all over h. Now the h's can cancel out, and then we can let h tend to 0, giving us that the derivative is then minus 4x plus 6. This answer you can always check using the derivative formula to make sure that you have got the right answer. Let us look at the next one. It says determine the derivative of y if this is the dy by dx, if this is the expression. So 8.2.1 dy by dx is then equal to the derivative of 2x squared, which is 4x, plus the derivative of a half x to the power 4, which is 4 times a half, which is 2x cubed, and the derivative of a constant is 0. So it is just 4x plus 2x cubed. Let us look at the next one, 8.2.2. Now this one here, it is not as straightforward as the one below, the one that we've just done, because we have no derivative rule for a quotient. So we will first have to simplify it. So we have x cubed minus 5x squared plus 4x all over x minus 4. I'm going to factorize the numerator. First, taking out a common factor x, we get x squared minus 5x plus 4 all over x minus 4. Then we want to factorize that. It's a trinomial, so we have x minus 4 times x minus 1 all over x minus 4. And then what happens are the x minus 4 can cancel. We can redistribute that x, so it's x squared minus x. So that's what's f of x. Now in this form, we are able to get the derivative. The derivative of x squared is 2x, and the derivative of x is minus x is minus 1. Okay, on to the last question. It says the tangent of the curve of y is equal to 2x squared minus 3x minus 5 is drawn at the point 2 and minus 3. A straight line parallel to the tangent through the y-intercept of the curve is drawn. Determine the equation of the line. So we have to find out what is the gradient of this line and what is the intercept of the line. So we know that the gradient is the same as the tangent. How do we get the gradient of a tangent? We get the derivative and evaluate it at the point of the tangent. So the tangent passing through a straight line parallel to the tangent passing through the y-intercept of the curve is drawn. Okay, so we want to first get the gradient. So we get the derivative of the equation of the line. So we have y is equal to 2x squared minus 3x minus 5. So we want to get the derivative. So dy by dx is equal to 4x minus 3. That's the derivative. And then to get the tangent, we evaluate it at the x where the tangent is. So we want dy by dx when x is equal to, what was it equal to? 2. So the x coordinate, the tangent is at that point. So we want when x is equal to 2. So this here is 4 times 2 minus 3, which is 8 minus 3, so it's 5. Therefore, we have that the gradient of the tangent and the line parallel to it is 5, because the line parallel to it has the same gradient. This line goes through the y-intercept, so we need to, so our c value is the y-intercept of this. So for the y-intercept of the graph, we make x equals 0. So we have y is equal to 2 times 0 squared minus 3 times 0 minus 5. So it is minus 5. So the y-intercept is then minus 5. Therefore, our equation, which would be mx plus c, to substitute the gradient, we know it is parallel to the tangent, so the gradient is 5. And we know that it goes through the y-intercept of this graph. So we know that its y-intercept is minus 5. And that would be the equation of the line parallel to the tangent at 2 and what was that coordinate? 2 and minus 3, and passing through the y-intercept of the curve. Okay, I hope that you have understood the video. Please watch our other videos on the papers and make sure to review the series if you were unsure or did not get high enough marks. Thank you for watching. Bye.